Hi, this is Ashok Kumar Bandla. Now, in this video, I would like to explain performance characteristics of instrument. In this, uh, we are moving for dynamic characteristics. Coming to dynamic characteristics, as we have already discussed, a set of criteria defined based on some differential equations. These are called dynamic characteristics. So I can conclude that dynamic characteristics which are varying with respect to time. That's why we can call them as dynamic characteristics. Now, coming to how many types of dynamic characteristics. First one, speed of response, fidelity, lag, dynamic error, dynamic range, bandwidth, settling time, time constant, uncertainty, correction, scale readability, input and output impedance. Total we have 12 dynamic characteristics are present for an instrument. We'll see one by one. Coming to speed of response. The name itself implies speed of response. If I want to measure any unknown quantity, if I give some input to the system, how much with how much speed the instrument can act to give the output. That is nothing but speed of response. It is activeness of the system. See the definition here. It is the speed with which the system responds to changes in the quantity to be measured. How much fast the instrument can act for the changes in the measured quantity. That is called speed of response. If speed of response is high, that instrument is reliable instrument. Next one, fidelity. Fidelity means faithfulness. Faithfulness in the sense trueness, reliableness. It indicates how faithfully the response reproduces the change in the input. For example, if I change the input parameters, correspondingly I should get the output. If we won't get the output corresponding to the changes in input, that is nothing but not reliable instrument. So it is the ability of an instrument to produce a wave shape identical to the wave shape of input with respect to time. This is called fidelity. Now coming to lag. Lag means delay. Delay in terms of time. The time delay taken by the measurement to produce the output to the response to the change in the quantity being measured. For example, if I change the input without any time delay, the instrument is in a position to give the output. That is nothing but lag. So, for any instrument, it will take some time delay. The time delay should be as much as less as possible for any instrument. Then only we can say that instrument is reliable instrument. If you see in the graph, see here dynamic lag. See this position, dynamic lag. Actually, I am giving input like this, but here I am getting the output. So this is the time delay we have between input parameters and output parameters. This distance should be as less as possible. Then only I can say instrument is said to be a good instrument. This is nothing but lag. Now coming to next one. dynamic error. The difference between, already in static characteristics we have studied about error. Error is nothing but the difference between true parameter to measuring quantity. That is nothing but error. But here coming for dynamic error, the difference between the value indicated by the measurement system and the true value of the quantity, which is function of time, is called dynamic error. Next, coming to dynamic range. The range of values of a certain quantity, for example, if you consider temperature, pressure, voltage, current, etc., whatever, the range of values of a certain quantity for which the measuring instrument can produce a faithful response. Faithful response is nothing but correct response. The range of values, for example, if you have the range from this position to this position, in this range of set of values, the instrument can able to produce faithful response. Beyond this particular range, it cannot produce correct response. You may get some deviation. The range at which instrument can produce faithful response is called dynamic range. So in this position, this is the range of dynamic. Now coming to bandwidth. It is very well known term. Bandwidth is the range of frequencies, lower frequency and higher frequency. For example, if you consider this one, this is lower frequency, this one, and consider this is, let it be, higher frequency. The range of frequencies, this is the range of frequencies with which the dynamic sensitivity of the system lies within the specific band of static sensitivity. Already we learned about sensitivity. Sensitivity is nothing but change in output by change in input. That is nothing but sensitivity. So the range of frequencies with which the dynamic sensitivity of the system lies within the specific band of static sensitivity of the system. Next one, settling time. The time required by the response of the system to reach and stay within the close range of the steady state output. Settling time is very, very important in control systems point of view. See in this graph, this is the output response we are getting like this. We are getting like this. We can have some oscillations. As the time is going on, the waveform is getting settled. Oscillations are getting settled. That how much time will take to settle down the oscillations, and it will take steady state condition. That is called settling time. If you see here, these much of oscillations are allowable. So here I have shown this is the settling time. Means settling time is nothing but the time taken to settle down, that is nothing but to reach the steady state condition of any response. That is called settling time. Next, coming to time constant. The time required by the response to reach 63.2% the final value. See here, this is the response I got, but time constant is nothing but the time taken to reach 63.2% of the final value. This is the position where 63.2%. So the time taken for which the waveform takes 63.2% of the output value. So this much of time it is taking. This much of time this is taking. So this is called time constant. Coming to next one, uncertainty. The variation of measured value from the true value of the unknown quantity is known as uncertainty. Once again, see the variation of measuring. What is meant by measuring? The unknown quantity to be measured. The variation of measured value from the true value of the unknown quantity. This is nothing but almost error. So the difference, how much the unknown quantity is varying from the true value, that is called uncertainty. Coming to correction, the algebraic difference between true value and the measured value of a quantity is known as correction. Correction is nothing but true value difference or minus measured value. We can consider like this. Next, scale readability. The extent to which the design of the scale of the measuring system enables the observer to read the indication on the scale. So, if that instrument is used by a particular observer, the observer can able to see the indication of the scale. So, the design of the scale of the measuring system enables the observer to read the indication of the scale. For example, I have my pointer is like this, pointer is moving in this way like this. This total system is observing by observer. So how much extent the observer can read the pointer which is moving from left to right. That is called scale readability. Last one, input and output impedance. The input and output impedances are the parameters which represent the characteristics of the system, such as electrical or electronic signal conditioner. The input and output impedances are the parameters which represent the characteristics of the system. The overall characteristics, we can get the one awareness or one familiar with the values of input and output impedance of any instrument. These are dynamic characteristics of instrument. So from the particular explanation, student can able to learn dynamic characteristics of instrument, which we have studied total 12 dynamic characteristics, right? So what is the important question we can get in exam point of view? Explain dynamic characteristics of instrument, or the same question can be asked in different way like how many dynamic characteristics are present for an instrument and explain. You may get this question either for 7 marks, or you can get specific dynamic characteristics like speed of response, explain about speed of response, fidelity, any 2 or 3 dynamic characteristics you get, and you may get for 3 marks in part A. You can get either in part B or you can get in part A. Okay, thank you.